Hey everyone, my name is Phil Carlinghouse. My talk is on toxoplasmosis. Let's get into it. So, the agent in question is Toxoplasma gondii, aka Toxo, comes from the family Sarcocystidae, and the genus is Toxoplasma. There's only one species of this gondii, and the nickname for this is Toxo. As we look to the right here, we see they have this sort of arc or bow shape to them. Arc or bow in Latin is Toxo, plasma is life, gondii is a name that was derived from the rodent it was first found in. And this photo was taken at 1,000 times total magnification under a light microscope, so they're not too small, not too big, kind of in line with what we might see from a eukaryotic parasite. So they're obligate intercellular protozoan parasites. They come from the Apicomplexa class. They're spore-forming, and they have 3 life stages: oocysts, tachyzoids, and bradyzoids. Because they come from this certain class, they have a different sort of structure and some different organelles we don't typically see. And because of this, they are just better at penetrating into cells, and then those organelles work in conjunction to suppress the immune system. All that's actually pretty interesting. I'm not going to go into that too much here, but if you're interested, look into this class of parasites. Because they're spore-forming, they also are quite resistant and persistent throughout the environment, and because of that, they're quite prevalent. Some mystery behind it: 1908, first identified in a rodent found in Tunisia, Africa, the gondii, by these 2 scientists. In 1923, the first case was found in an infant, as they had contracted it from their parents. It was passed through from the mother. And it was not known at the time that it was actually caused by the parasite, but we know now, based off of modern birth defect signs and symptoms, that the ones that were recorded are the same. So it was found that that was the first case. In 1937, it was then identified as an obligate intercellular parasite, as given through a test of some infected meat into some subjects. They contracted it too. Then later in 1965, transmission from raw meat was discovered. So with any sort of animal, you eat it, pork, chicken, if it's raw or underdone, it can then be passed on to you, and then it can reproduce in your own body. So some strains here. There are 3 main strains, but there are 15 total, but 3 main ones that cause most of the infections. Type 1, Type 2, and Type 3. Type 1 is most rare but most virulent. Type 2 is not nearly as virulent, and Type 3 also not nearly as virulent, but Type 2 and Type 3 are most common, Type 2 being even more common in North America. However, Type 3 is more seen in animals versus humans. As we look to South America, though, they have any number of other strains, not just these main 3. They have some other ones that are atypical. Because of this, we see there's more genetic diversity, and because of that, there is some differences in some virulence factors. So 40 to 80% of people are infected in South America, whereas in North America, 10 to 20%. Now, there are cats in North America and in South America, so this might have some effect on how you are affected, which strain is being involved. Pathogenesis: it's only able to sexually reproduce within cats. However, cats are all over the world. The only continent they're not on is Antarctica. And so, because they're like any other animal, they eat things, and then they have to get it out the other end. And so, in their feces, they are able to shed these oocysts, which then become sporulated after a few days. About 3 to 5 days is how long it takes. This can then go into the soil, into the waterways, and one cyst has thousands of spores, and there's tens of thousands of these within a single dropping. So there is tons of this being spread. And because of that, it only takes a little bit, and it's able to go all over. There are cats everywhere, so it's able to go through the fecal oral route, and is picked up by farm animals, birds, rats, then also can get on our produce through soil and water that's been infected. And as it gets into the body, it then persists in the tissues and embeds itself, and then it forms into these tissue cysts, which is just a clumping of all these tachyzoids, which have now turned into bradyzoids within the tissue cysts. And then if you eat this raw or underdone, the meat that is, you can also catch this. And then you can also get it from transplants, blood transfusions, and you can give it to your child through the transplacental route. Sorry. So these 3 main stages, coming back to that real quick: oocysts most widespread through the environment. Bradyzoids don't reproduce nearly as quickly. Tachyzoids do produce more quickly. They kind of come before bradyzoids, and all of the cysts are actually made up of the bradyzoids. The tachyzoids are what kind of spread out throughout the body. So The study found that rats actually lost their aversion to cat urine, which typically we don't think of rats and cats as being best friends. But they actually lost their aversion and actually started to like cat urine a little bit. So because of that, they're hanging around areas where cats are more, and cats are able to eat them a bit easier. So it's able to get into the cat's body more easily that way, and then sexually reproduce even quicker because of that. So because of that, like we saw these sort of interesting behavior, almost mind control things going on in rats. We thought maybe there were also some changes in other mammals, so we looked at humans. So as looking at some IgG antibodies, all these were found to be higher in the blood of suicide attempters who were schizophrenic, and because of that, like we looked at a schizophrenic population, because there is a loose correlation that toxo might induce schizophrenia in people. It was also found that there's more than 2 times higher risk for auto accident, and also interestingly, there's a 1.4 times more likely chance to go into business, and then a 1.7 times higher chance to go into management and entrepreneurship positions. So maybe our friends on the other side of campus might have toxo. Who knows? Could be interesting. So transmission, you can get this through tissue that has been infected. So the zoonotic transmission. It can also go through the fecal-oral route, so in water, or fomites that have also been infected, or the transplacental route. So they can be transferred through the blood to the fetus in the womb. Pathology: 90% of people are asymptomatic. You don't have to worry that much about it if you have a good immune system. Like most people, if it's like a normal immune system, you're going to be fine. Your body's able to fight this off pretty good. However, if you do have a slightly weakened immune system, you might see some fever, fatigue, malaise, and headaches, swollen lymph nodes as your body is fighting it off, myalgia, which is just kind of muscle soreness and weakness. And then if you are pregnant, your child might also have some impacts, which all those are actually a lot worse. And then people who are HIV positive and things like that, they do experience some more severe effects along with the sort of infants that we'll see. So as we look to people who have this weakened immune system, they can have some inflammation of their lung tissue. So seen on the left and to the right, we see a normal chest cavity. Then we look to the right, and it looks more inflamed. They can also have inflammation of their brain and the covering meninges, and then inflammation of the heart tissue as well. So all these are kind of caused by all those cells penetrating into the tissue and then reproducing and creating these cysts, which causes an inflammation reaction. And if we look to congenital, I didn't want to include any actual pictures because they're really just heartbreaking and sad, but if you'd like to see them, they're out there, and it really shows how kind of awful this can be for kids. So, I had only included these other graphics that aren't nearly as kind of like descriptive of what's going on, just because it's really awful to see. But if you see this, we have some larger ventricles here, more filled with CSF because the sylvian duct is blocked off. Microcephaly can also happen, so a smaller size of the head. And then you can also get ocular toxoplasmosis, so that's also seen quite a bit, which can also cause blindness and pain. The overall immune response is pretty complicated, so I'm not going to get into it here. But the innate and adaptive is involved here. It's it's mostly IL-12 and IFN gamma that activates T cells, natural killer cells, and B cells. However, other cells are also activated by all those. It's a highly complicated response. I have a graphic over here to show it a little bit, but I'm not going to get into that too much right now. Incidence and prevalence. It's thought that up to 50% of the population of the world has it. However, a more conservative estimate is somewhere between 25 to 30%, and that is also 200,000 new cases a year given from a mother who is infected. And it's thought that humid climates are more susceptible. So as we see here on this map, more areas around the equator have issues. However, it's not entirely consistent with that, because we also see a number of people over in France that have large amounts as well. So how do we prevent this? You can wear gloves while changing the litter box, you can wash your hands, and you can cook food to the right temperature, right? So like we want this to be 145 or higher, just make sure it's really not raw, right? However, most people really don't need to worry about this. It's mostly people who do have a weakened immune system or pregnant women. So if you are pregnant, you should stay away from cats. If you have a cat and you're forced to be around it, make sure you wash your hands after touching it. But mostly the biggest issue is making sure when you're changing the litter box, you wear gloves and you wash your hands afterwards, because it can be picked up through the feces there. If you do start showing some symptoms, you do need to be treated, or some antibiotic regimens you can get on. A combination of these two antibiotics can work together, but there's no vaccine right now. It's just we're just not at that stage. And here are my references. Thank you guys for listening. It's been a pleasure.